Today we are going to talk about functions. To start off with a few vocab. The vocabs are relation, a set of order pairs, domain, a set of all input values, they are x values for a relation, range, a set of all output values, they are the y values for the relation. And I also want you to keep in mind that some of the things that we have been talking about is like this. You have the x and the y, okay? And then throughout the whole statistics, we also have something that's related to that. So x is going to be the domain and also range now. That's what we're going to talk about today. And you have the x and the fx. So really, fx is just another word for y. Then you guys have the input and the output. And you also have the independent. And then you also have the dependent. Think from chapter 2. That's the explanatory. And you have the response. All those things depends on the situation, means kind of the same thing. Doing your problems, keep that in mind. I don't know which one will be helpful, but as time we go on discussing using those words, let's take a look. So domain is all the x and range is also all the y's. And if you think about this, I also want you to think about it, except the independent and dependent, everybody else is alphabeticalized. X before y, domain before range, input before output, explanatory before response. Okay, I hope that helped. Except being independent and somebody who is dependent. The very first example they are asking is determine the domain in the range. Don't forget, domain is before range, so domain is the x. Domain is mine, 7, 24, 38, and then 7. You say, oh, Miss Wiesman, do I have to write again? No, you don't. So that's 7, already written, and 50. And range is going to be 2, -9. Oh, 2 again, so we don't have to write it. 8 and 8. So that's your domain and that's your range. So this is your x, that's your y. So that's all you have to do for the order pairs. So you guys try the second one and I'll put the answer down. Number 2, the domain is the x value, 6, 16, 35, 6, and 59. So I only wrote down 6 once. And range is 4, -2, 2. And then sometimes you guys will see that the book answer or some other books, they might put braces on that because that's a set notation. You can definitely put that there. Put it down. Okay, so those are all acceptable. Also, another thing we're going to do is we're going to identify what is our x value and what is our y value. So let's take a look at number 3 to talk about what are all our x value. Now, there's a couple different ways you can describe by symbol. You can describe by words. I will tell you guys how to do both, and then you guys would answer the question accordingly when the test or quiz is asking. Couple things from before in the set notation and the interval notation. So we're going to use that idea. Remember, the set notation is the braces and the interval notation is the brackets and parentheses. So what we're going to do is I'm going to tell you guys how to do both of them. Now, we are going to talk about x value. Now, x value goes first because that's domain. It's alphabetical order if you guys think about it. X before y, D before R, if you can try to remember that way. X value is all those value going this way. And the y value is all the value going this way. There's a little trick to it. If you imagine you're putting a box around this graph. Now, the problem is, if you put a box around this graph, you really have something like this and this because it keeps. And then if you start box in, if you notice, there's an arrow there. And if the arrow is there, it's going to push the box out. That means this wall right here is going to get pushed out. And this wall right here is going to get pushed up. I hope you guys understand that. The part that gets pushed out and pushed up, that is infinity because that's going positive direction. And the top right here is also going to positive infinity. But did you guys notice from what we have before the purple box. If I take the purple box away, there is no arrows on the bottom. So therefore, that's actually a dot right there. That is going to tell you, hint, 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 use a bracket. So we're going to do interval notation. So domain in the interval notation is going to be x. Well, if you're thinking about x at 1, and then how is it carry all the way through for all your x value? That's positive infinity. If you look at range, if you look it up from that dot, it's going to be at where? Well, it starts at y equals 0 because that is really comma y0. See that? That's your domain and that's your range, x and y. So y is going to start at 0 and going towards positive infinity. Set notation, you can write it as this. Domain is equal to, set notation is going to be x is greater than equal to 1. That's a set notation. And range is going to be y, and y is going to be greater than equal to 0. And I hope you guys remember, if we use an equal sign, that means the dot is colored in. It's not open circle. Okay? And there's also another way you can take a look at a problem like this. And I'm going to explain it to you again. Now, I also want you guys to think about it. The arrow is going towards the positive on x and positive on y. Okay? Some of you guys might already noticed. If you're looking at the x, if we are looking at the y, list the smaller number, list the bigger number for x and y right here. Now, number 4, there's another easier way to think about this. I will actually write down all the corners or the turning points and all the ends. If you guys can think about this as points, let's label all the points. So the points for this guy right here, that's going to be at 0, 1. And are you guys okay if I say this arrow keep on going? That's going to go to positive infinity, and positive infinity, that's x and that's y. Going towards positive side for the x, going to positive side for the y right there. Okay, then I'm also going to label this one, this arrow right here, and that's going to be going towards x this way. That's going to be negative infinity, and going up this way towards up, that's a positive infinity for the y. So that's x and that's y. Okay, so now because of that, so when you do it this way, you have to make sure your arrows has x and y coordinates, your points, vertex, or your any kind of points have x, y coordinates. The reason for that is now to write down your interval notation, I'm going to pick the smallest number first. So domain, smallest number of x. The smallest number for x is going to be, this is x, that's x, this is x. Which one is the smallest? Oh wait, it's not 0. It's actually negative infinity that goes on forever. So therefore, your domain is infinity. So therefore, remember we put down parentheses. So negative infinity. That's your x. Now let's look at your y. Your y is going to be this guy, and this guy. Ooh, who has the smallest? We always pick smaller first. Oh, I'm sorry. The y is going to be the biggest. You have to make sure your arrows has x and y coordinates. Your points, vertex, or your any kind of points have x, y coordinates. The reason for that is now to write down your interval notation, I'm going to pick the smallest number first. So domain, smallest number of x. The smallest number for x is going to be, this is x, that's x, this is x. Which one is the smallest? Oh wait, it's not 0. It's actually negative infinity that goes on forever. So therefore, your domain is infinity. So therefore, remember we put down parentheses. So negative infinity. That's your x. So if you actually look at the whole situation, I'm going to mark my x for you. This is your x, and that's your x, and this is your x. So for the domain, what you're going to do is going to be smallest x and the biggest x. So in this case, smallest x is negative infinity, 0, or positive infinity. Smallest x in this case will be negative infinity. And then the biggest x value is going to be positive infinity. Okay? And then the next part, if you take a look, the next, the y value. So I want to mark it in the y value for you. And let's use green. So this is the y value in green. Okay? And then if you really write it out, that's going to be range is going to be, again, smallest value. Now take a look at the green. It's positive infinity, 1, and positive infinity. So in this case, which one is the smallest value between between 1 and positive infinity? Well, it will be 1. And because it's 1, it's a number that we recognize, and it is a number that has an endpoint, so it's going to be 1, comma, positive infinity, which is going to be the biggest number, smallest number, biggest number, positive infinity is going to be your range. That's one way you can do it. Now then, what we're going to do is we're going to do it in set notation. And if you do it in set notation, domain is going to equal to all real number, or you can say, like it like this, all real number. It's a R with a slash through it. And then the range is going to be the set notation, y, not x. y is greater than equal to 1. And for the other one, if you want to do it that way, is okay, but you can also do it the way that is going to be x is an element of all real number. That's the proper way to do it. That's just a curvy R. Let me do it one more time and make it better. A curvy R with a slash through it. Okay? So either way is totally okay. Guys, somehow one of my definition got deleted. So please, I'm gonna try to add back to your notes, but make sure you jot this down. The definition of function, I'm gonna write it down and then tell you guys, and then explain it to you guys. Okay, next big thing. It's the definition about function. So what is a function? A function is a relation in which every value in the domain is paired with or assigned to exactly one value in the range. So therefore, the domain, if this easier way to remember, domain cannot show up more than once. So think about this. X cannot show up more than once. Y could, but not X. So let's look at the example 5. So on example 5, if you look at it, you are looking at the X right here. And if you notice, X actually show up twice and pair with different numbers. So therefore, that is not a function. And another way, if you want to think about this, if I draw the picture like in the bubble, if I have 5 and match up to 4, and then 2 match up to 4, and then 5 match up again to 3. Notice I have 5 has 2 match up 2 numbers. That is not allowed. So X right here cannot be used. The value in X cannot be used more than once. Okay? The value in X, which is 5 right here, if you look at it, it was using paired up with 4 and 3, and that is not allowed. But you say, but Miss Wiesman, but the Y get to use it twice. It's okay, but it's just only the X. And the reason for that is if you even plot the points, you have 1, 2, 3, 4, 5, 1, 2, 3, 4. There's that point. And then you have 1, 2, 1, 2, 3, 4 right here. And then if you have 1, 2, 3, 4, 5, and 3. Did you notice the line lines up and down? And when you lines up and down, that's not allowed. And we are going to talk about vertical line testing, and eventually you will see. If you can draw the line up and down, and 2 points lay on that up and down line, it's called the vertical line testing. Therefore, it's not going to be a function. So I'm showing you 3 different ways to tell something that's not a function. Okay, try example 6. If you circle the X value, was any one of them repeated? No. So therefore, this is a function. And you should be able to tell me what is my domain. My domain is the X value, which is in this case 7, -2, 2, and 3. And you should also be able to tell me what's the Y value. Y value in this case will be 5, -4, -1, and -70. And now another way we can take a look at the domain and range. Again, if domain is used twice, therefore it's not going to be a function. So number 7, is that a function or not? Well, it's not going to be a function because the domain is using twice. Twice here, twice here. So not a function. And next one is number 8. It's called the vertical line testing. Vertical line test. And I kind of tell you guys about it above in number 5. So what does vertical line testing? Usually if it's in class, I would just roll a pencil. But if you can, because you can see it, I'm going to just draw the line. Only vertical lines, that means up and down. If I draw that line up and down and hit the graph at more than one place, in this case right here, and right here. That means they failed the vertical line testing. So therefore, this is not a function. But you say, but Mr. Wiesman, what happens if I draw it very in, like right here, only touch one point? Well, that's fine, but then the rest of the graph does not. So if there's one area, just one little thing you can find, it doesn't fulfill the requirement, that means that's not a function on it already. So now, what is the domain and the range of this one? Well, domain and range of this guy is kind of funny because you literally can put a box around this little oval shape. And if you do that, you can say, oh, I have the lowest points right here. That's going to be at 0, -4. I'm going to have a point right here that's going to be 4, 0. I'm going to have a point right here that's going to be -4, 0. Now, if you don't want to even put the box there, it still works. Remember I told you guys, name all the points that turns. Okay? Since there's no arrow, you got to pick out all the points that is furthest apart. So up here, this is going to be at 0, 4. Now the domain, remember I said, is the smallest x. So here's my x. Well, what's my smallest x? Well, my smallest x right now is going to be -4, 0, 4, 0. Well, smallest x, I have exact number, so it's going to be a bracket, -4 and +4, small to the biggest. And it's bracket because we have exact number. Range. What is the smallest? What is the biggest? Well, the smallest is going to be, well, this is all the y value. What's my smallest? Oh, my smallest is -4 right here on the bottom. And what's the biggest one? +4 again. Oh, I'm sorry, that's a 3 actually. So that should be a 3. That should be a 3. And the x value should be a 3 and -3. -3 and 3. Okay. And then to do it in set notation domain is going to be x is going to be between +3 and -3, and range is going to be the y value at -4 less than or equal to y less than or equal to 4. And that is how that problem going to be done. Now you have to recognize both symbol. You don't have to worry about one set or the other. If you have to write the answer, I would let you get away. You can do it either one, but you need to make sure you pick one that stick with it. But you should recognize it, because I don't know when the test come down to multiple choice which one you're going to get. Okay? Next problem is really easy, but you have to listen carefully. Okay, so the next problem is number 9, and the answer literally is there. You just have to identify this. And just so you know, some of the people in calculus do this. Okay, so please pay attention, or pre-calc. So in this case, you have, this is just saying, hey, if my value right in here, if this is x, that means x at 1. If you are looking at x at 1 right here, what is my y value going to be? My y value is going to be going up. Hey, Miss Wiesman, but that's an open circle. So I need to find one that's closed circle. So therefore the value is at 2. All right. So now next one I'm going to look at is 0. When x is at 0, what's my y value? When x is 0, x is 0 is right here. Right here. And what's my y value? Looking it up right here. That's going to be at 1. Okay. Next one. If x is at -4, -4. Let's see. 1, 2, 3, 4. -4. X is at -4. Oh, I don't have anything. None. Okay. And then the next one is going to be f equals -3. -3 right here. None. Let's change that into a +3. So +3, let's go this way. 1, 2, 3. Right here is going up. That's equal to 3. Okay. Question. Let me know if you have. Next thing, we're going to talk about function notation. And I want to just do a comparison between equation in 2 variables and function notation so you understand what I'm talking about at the very beginning when I give you this chart and saying, hey guys, they really mean the same thing. This is x, this is just fx. That's just the way we write it. Okay, so first equation I'm going to give you is going to be something like y equals 3x. Okay, number 1. Now, in function notation, they literally just change it. F of x, that means whatever the value you're going to plug in for your x, and then that's going to be your y equals 3x. So whatever number you plug in for your x, you put it in 3 times x, and you're done. Or another way to look at it, if I have y equals -4x plus 1, and your function notation is just going to be f of x equals -4x plus 1. They are exactly the same thing. The only difference is if you look at the equation in 2 variables, they will eventually telling you x equals something and you plug it in. At function notation, the x value will be inside the parenthesis. So then let's take a look at the example. Look at example number 10a. What they are saying is, okay, f of x is equal to x squared minus x plus 10. What happened when x equals 1? That means the 1 goes into here and replace everybody else that has an x. So the new line should look like this. F of 1 means 1 squared minus 1 plus 10. That's all. I'm just replacing all my x value with 1. It's just like substitution. So when you work it out, that's just going to be 1 minus 1 plus 10. And the answer would be 10. Done. Okay? I want you guys to try the other two yourself and come back and check with the answer. The number for number 10, A is 10, B is 40, and C is 10. If you have any question, please let me know. You guys try number 11. So this one is for the number 12. It's a little bit tricky, so let me just go through and explain. First one is just plug in 0, square root 7, we're just going to leave it square root 7. Now, letter B is if you plug in -10 for x, in this case, you are going to have -3. And because you have a -3, it's no real solution for now. Eventually, we're going to learn how to take care of it. And the next one, you have W. Now, W is being replaced with, X is being replaced with a W. So you just pretty much put down W plus 7, square root of W plus 7. You are done. There's nothing more than that. I also want you guys to try number 12. And there's a couple little things. When you try number 12, I need to go through it. So pause it. Let's see how far you guys get. So I think number 12a, just plug in the 2 where the x is, which is 2 minus 3. That's going to give you a -1. That should be pretty easy, 4 over -1. And the negative sign can be on top, on bottom, or just with a whole number, but you can only have one. So that one should be the same. That should be easy. Now, B is just going to be 5 on the bottom, -5 minus 3 is going to be -8. It's like you're losing $5, you lose another $3. So that's -8. Now, notice if you reduce it, it really can be 1 over -2. But I can also write it as negative sign in the middle, 1 over 2. That's okay, both ways. Now, 12C is a little tricky. We plug in the 3. 3 minus 3 is 0. 4 over 0 is undefined. Same thing like the slope when you have bottom equals 0 is undefined. The reason for that is it doesn't work. This fraction will not make sense. So it's undefined. You cannot figure out. You cannot do it. But if you leave it, any answer is 4 over 0, and you didn't tell me it's undefined, you will get the answer wrong. That means you did not simplify all the way. It's like leaving 4 over 4. You did not tell me that's 1. So if you are going to get this kind of answer, I want the word undefined. Very, very important. Okay? Next. So for example number 13, it's really again f of x equals -3 over 2x minus 2. I want you to pretend that's y equals -3 over 2x minus 2. So in this case by now you should know m is equal to -3 over 2, work the same way. B equals -2. So we should be able to plot the line b at -2 right here. And the slope is -3 over 2. So down 3, 1, 2, 3 over to the right 2, down 3 over right 2. And go the other way, you should be able to get up 3 over to the left 2, up 3 over to the left 2. And the same thing. And then you draw the line. And that is the notes for 4.7. The function and function notation. Thank you.